Hi everybody, if x, y and z are natural numbers, so we have x plus y plus under root z is equals to 670 and x plus under root y plus z is equals to 940 and finally we have under root x plus y plus z is equals to 544. Then find the value of x, y and z. So first you please give your trial to this question. Now this is our given information and now look at x and y. These are two natural numbers. This is our given information and we are adding two natural numbers plus under root z and this gives us 670 which is also a natural number. It means the z is a perfect square, so we are able to express z is equals to the square of something, let's say it's c square, and similarly doing this same thing in our this equation, so we are able to express y is equals to b square, and similarly in this equation we are able to express z is equals to a square. Now this is our final equation after substituting the values, and now looking at our this equation, now subtracting this with this equation, so what we have is this, now cancelling b square with this b square and making the pair of a square with this minus a square and this c with this minus c square, and finally we have this. Now subtracting this equation with our third equation, so we have this, and now cancelling c square with this negative c square and making the pair of a square with this negative a and b with this negative b square, so finally we have this. Now similarly subtracting this equation with our second equation, so what we have is this. Now we find these three equations and now looking in our first equation, and we know that ABCs are natural numbers because x, y and z are also natural numbers. So we can set a times a minus 1 is greater than c times c minus 1 because subtracting this value of a times a minus 1 with c times c minus 1 gives us a natural number. So it means this is quite obvious that a times a minus 1 is greater than c times c minus 1. Similarly, looking in our this equation, c times c minus 1 minus b times b minus 1 gives us a natural number. So again quite obvious that c times c minus 1 is greater than b times b minus 1. So final equation that we have is a times a minus 1 is greater than c times c minus 1 and c times c minus 1 is greater than b times b minus 1. So this is our equation that we got some. Now this is our information that we find. So looking in our first equation, we have c times c minus 1 minus b times b minus 1 is equals to 270. Now adding both sides by b times b minus 1, so we have something like this. Now looking in this part of our inequality, so we have c times c minus 1 is greater than b times b minus 1, and looking in our below information that we have, this is c times c minus 1 is equals to 207 plus b times b minus 1. So if b times b minus 1 is greater than c, so we can say c times c minus 1 is also greater than 270. So using this inequality to find the value of c, so we have c square minus c is greater than 270. Now subtracting both sides by 270, so we have this. So first we find what are the values of c which satisfies this equation is equals to 0. So now using quadratic formula, so we have c is equals to negative b plus or minus the square root of b square minus 4ac divided by 2 times of a. So we can express that. So now we have c is equals to 1 plus or minus 332.88 divided by 2. So we can place the value of plus in the place of plus or minus. So finally we have this. So we have c is equals to 16.93. This is the approximate value of c which satisfies our inequality is equals to 0. So all the values of c which satisfies this inequality has to be greater than the value of c which satisfies this equation is equals to 0. So c is equals to 17, 18, 19, 20, 21 and so more. And we use these values of c for finding our final answer. So this is our given information about c, and we can use our this equation that we have find. So a times a minus 1 minus c times c minus 1 is equals to 226. Now if c is equals to 17, then we have a times a minus 1 is equals to 398. So factorizing 398 gives us equals to 2 times of 199, and we can do not factorize this more because 199 is a prime number. So our value of a times a minus 1 is equals to 2 times 199. But this doesn't satisfy a, because if we consider a is equals to 199, then a minus 1 can't be equal to 2, because if we satisfy a is equal to 199, then on the place of 2 we have 198, but this is not looking like here, so we can cancel the value of 17 in the place of c. This doesn't satisfy the value of a. So now we consider c is equals to 18, so we have a times a minus 1 is equals to 432. Now factorizing 432 gives us something like this, and so we have a times a minus 1 is equals to this all stuff. But same thing here, if we consider a is equals to this, and if we look at a minus 1, this doesn't satisfy, the remaining factors doesn't satisfy a minus 1. And I'm not saying you consider first 4a and then 3 3's. You can also consider like 2, first we multiply 2 3's and then remaining 3 3's with another 2. But you will not see the pattern here. Now considering c is equals to 19 gives us a times a minus 1 is equals to 468, and if we factorize 468, we got something like this. So we have a times a minus 1 is equals to the factors of 468. So again, if we consider a is equals to factors of a times 3, and then remaining factors doesn't satisfy the value of a minus 1. So considering c is equals to 19 is again wrong. So now if we consider c is equals to 20. So considering c is equals to 20 gives us a times a minus 1 is equals to 506, and factorizing 506 gives us is equals to 2 times 11 times 23, and I am seeing something here. So now if we consider a is equals to 23, then remaining factors are 2 times 11, and if we multiply this we got 22, and this is exactly like subtracting a with minus 1. So a minus 1 is equal to 22, and then remaining factors satisfies this equation. It means considering c is equals to 20 satisfies the value of a. So it means we have c is equals to 20 and a is equals to 23, and with the help of that we will find the value of b. So we have a times a minus 1 minus b times b minus 1 is equals to 396, and we have c is equals to 20 and a is equals to 23. So finally we have 23 times 22 minus b times b minus 1 is equals to 396. So we have b times b minus 1 is equals to 11 times 10. So considering b is equals to 11 satisfies the value of b minus 1, which is 10. So we have finally we have b is equals to 11. So looking at the value of a, b, c, we have got them, and z is equals to c square, y is equals to b square, and x is equals to a square. So finally we have x is equals to 529 and y is equals to 121 and z is equals to 400, and that is our correct answer.